All right, welcome back, Hononegah. Algebra 1. New chapter now. We're going to talk about radicals in this chapter. 9.1, simplifying radical expressions. So how do I know if I have, if I'm simplifying? Remember, this is not a decimal situation, so you're not just going to put number in your calculator and just get the decimal. About simplifying something. So when do I know something is simple? When there's no perfect square factors that are still left. Inside the radical, if there's no fraction inside the radical. And there's no radical in the denominator. Bottom of the fraction. Now you really should know the first 12 perfect squares. You don't need to know one, but 4, 9, 16, 25. I know I went out of order there, so I probably should change that. 6, 25, 36, 49, 60. We're up to 8, 9, 10, 11, and 12. So you really should know those first 12 perfect squares kind of by heart. If you're going to use method 1, on the next page. So here we go. What is a perfect square? Anytime you square an integer, the result is a perfect square. So if you take 5 squared, 5, that's a perfect square. And we did this a little bit, obviously, previously when we did difference of squares with factoring. So knowing your perfect squares will be very helpful. In this particular case. So here we go. There's two methods. I don't usually do this method, but it is obviously legitimate. I think it requires a higher order. I need to know what is the biggest perfect square that can come out of 300. Well, 100 is divisible into 300. So I can basically divide this into two radicals. 100 times 3. Now, 100 is a perfect square. It's 10, and then so the answer to this simplifying is 10 square root of 3. So if you know, this is what happens when you, here's what happens if you don't find the biggest perfect square. So let's say I decided, you know, I get 25 times and so what happens is you won't get, this will be an incorrect answer because 12 still has a perfect square. And so that's 2 square roots of 3. And so again, it's going to cause much more pain if you do not know the perfect, the largest perfect square. So again, the largest perfect square would be 16 is divisible into 48. And so the answer to the question is 4 square roots of 3. So you really, really, really need to know your perfect squares, and then what's divisible. What perfect square would be divisible into that? And this is not the method that I normally do. The second method is what I normally do. It's called prime factorization. Divide this out into prime numbers. And the prime numbers that normally you would use would be like 2, 3, 5, 7. So this is divisible by 2. 150 is again divisible by 2. 75 is divisible by 3. And 25 is divisible by 5. And here's what happens. If there's a pair of any number, it goes out of the radical. And if there's a pair of any number, it goes out of the radical. And you're only allowed to use the bottom of the tree. And so the 5 and the 2 come out. So 5 times 2 both come out, and they're 10. And then the 3 that didn't have a pair is left inside the radical. And I like to refer to this as the rules of dating. Basically, if you have a pair, you get to go out. And if you're single, you have to stay in. Now, let's do it again. 2 times 24, 2 times 12, 2 times 6, and 2 times 3. A pair of 2s and a pair of 2s, they both come out. Single 3. So you notice that from the previous examples that I just did, I got the exact same answer doing it in the prime factorization instead of taking out the largest perfect square. So for the most part, I always do it in method 2, but obviously method 1 does work if you're good at it. Basically now we're simplifying the number and simplifying the letters. 25, if I broke that down, it is just 5 with no singles left over. There's a pair of 5s. Now let's talk about x cubed. Remember, you're looking for pairs. So there's one pair that gets to go out, but there's a single x that's left over. So basically what inside the radical is what is left over after you have taken the pairs out. So 3 times 9, 3 times 3. A pair of 3s, single 3. 1x, no pairs. 2y's, it makes one pair.